This section gives you a small taste of mathematical functions. If you end up taking our college algebra course, you'll get a big taste of functions. You'll learn quite a bit about them. But for intermediate algebra, it's just an introduction, mainly to get used to the notation form of functions, which has its own conveniences. So anyway, what is a mathematical function? Sort of distilled to its simplest, a mathematical function says that for every input there is a unique output. All right, so I'll expand on that as I draw some pictures and talk about it more. But let me start with a function. And this one is, well, it's one of my favorites. Y equals x cubed minus 9x. And I'm going to draw the graph of this function. You're going to have to take my word for it that this is what the graph looks like for now. But anyway, here's what it looks like. Now we're going to do graphing in the next section you study, but I think you'll get an idea from this what's going on. All right, this function resembles this shape. Comes up, goes down, comes back up again. And it's symmetric to the origin. The intercepts, the x-intercepts, are at 3 and -3, and also at 0. Where it tops out and bottoms out here, I'm not sure. I think if I remember it's around 10, give or take. It's not exactly in the middle here. Actually, I think the bottom is at the square root of 3, if I remember correctly. But anyway, it's a shape we call a cubic function. All right, now here's what makes this one a function. If you think of the x values, and the x's are along the horizontal axis, and the y values are along the vertical axis. You think of the x values as input values, then here's an input from this x, and this x value, whatever that number is, matches up to this output. So here's the input value, and coming across, this would be the output value. So the x, the horizontal, is the input, and the vertical is the output. If I go over to the other side, we'll see the same thing. For example, if I jump to here, if this x input is used, then there's my output. All right, well, so to make it a function, we want to know if each input gives you a single output. So each input leads to a single output. All right, you might wonder, quite reasonably, why in the world that would be so important. Well, it does make life so much easier if we only use functions. So, for example, my calculator's in the other room, but your calculators, every button on your calculator that does something, that computes something, is a function key. And so it takes the input that's on your screen, or in some cases what you've entered, the last few steps, and then you whack that key, and out comes another value on the screen, which is your output, input to output. Now, if there was more than one output, it would not be a function. And if there's more than one output, how would your calculator give it to you? So anyway, that's kind of the idea there. It's not that there are things that are not functions that are not interesting. There are some very interesting non-functions, but in math we tend to classify things into categories, and functions is a nice category. Now another view of this is a function is a relationship between input and output. Now what you'll normally see in this course is the input and output. The input is x, the output is y. And so that's the typical way of thinking about it in terms of input versus output. All right. Well, there are other functions that I can list here quite easily. Let me give you a couple of examples. For example, That didn't erase very good, did it? Okay. Y equals to 4x plus 7. There's a function. Every time you plug a number into x, multiply by 4, add 7, out comes an output value y. And by the way, this function looks kind of like this. It's a line. Okay. Here's another one. Y equals to the square root of x. And the square root function looks like this. It starts at the origin and goes off this way. And there's nothing to the left as far as the graph, because to the left here are the negative x values. And if you plug in a negative number, then you're taking the square root of a negative. That does not give you a real number. It is something we're going to study later in the course. They're called complex numbers or imaginary numbers, but we can't graph with it. So you could say that, well, okay, there are no input values to the left. Nevertheless, there are input values. So as long as there are input values, it might qualify as a function. This one is because, again, every time you plug an x in, you can get a single y value up here. So one thing you'll start seeing is that the graphs of functions have this commonality. If you draw a line through a function, then a vertical line will hit a function at most in one place. Now this vertical line misses the function, but here it hits it in one place. Same there. Same with the first function I drew up there, that cubic equation. All right, let me contrast this with a non-function. And I need to erase the board for that. This happens to be a non-function. X squared plus y squared equals 25. Now, the looks of it, graphically, it's a circle with radius 5. So let me sketch that. And again, it's something that for the moment you're going to have to accept on a bit of faith. We do study circles in college algebra. But you'll find out that this one is a circle with the center at the origin and a radius of 5 units all the way around. So why is this not a function? It's because it's possible to get two outputs from one input. So for example, if I plug in 3, then I can get this output, which ends up being 4, or I could get this output, which could be minus 4. Let me do that in chart form. So I'll draw a little XY chart. And again, input we're going to think of as X and output as Y. You can loosen those definitions of input and output later, but we keep it simple here in algebra. Okay, if X is 3, then y could be 4. Or if x is 3, y could be negative 4. Now, you can easily check to see that these pairs of numbers both fit this equation. And what's happening when you square the y value, you get a positive number. So I can feed a 4 or a negative 4, I'll still get a 16 here, I'll get a 9 here. 9 plus 16 is 25. So this single input of 3 leads to, in this case, 2 outputs. Other functions could give you more than 2 outputs. There are functions that give you infinitely many outputs. So you would study those first. You would first see them in a trigonometry course. Well, the idea here graphically is that a vertical line, if it hits a graph in 2 or more places, if any vertical line can hit a graph in 2 or more places, then that graph does not represent a function. And sure enough, that's what happened here. These vertical lines touch in at least 2 places. So that disqualifies it as being a function. Okay, well, our next topic is the notation for functions, and that's really what it's about in this course, is learning the notation. But I think it's important to understand a little bit of the why are you doing this business. So anyway, we'll go on to that next topic.